Hello everyone, this is Mayank again. So in this video we'll be going through this problem, number of ways to paint n into 3 grid. So this is LeetCode's today's daily problem, and this problem basically states that you have a grid of size n into 3 and you want to paint each cell of the grid which is with exactly one of the three colors, which is red, yellow or green. Okay, so while making sure that you no two adjacent cells have the same color. Okay, that is basically no two cells that share vertical or horizontal sides that have the same color. Okay, so given n the number of the rows of the grid, we need to return the number of ways you can paint the grid as the answer may grow large, so the answer must be computed modulo. Okay, so if you see, this problem basically states that we are given an n cross 3 grid and exactly three colors. Okay, so we must paint the grid such that adjacent cells, basically all the side cells, one beside other cells, either horizontally or vertically, should not have the same color. Okay, and cells in the same column of the adjacent row cannot have the same color. Okay, so we need to count how many valid ways we can paint the grid. Okay, so in this problem basically is hard because not because we are going to use DP or regression. I think it's because of the intuition. Okay, if you see, the acceptance rate of this problem is 70%, so it's pretty good, not that hard. Okay, we just need to find out a way or a good intuition to solve it. Okay, so what we are going to do, what we need to do here, we only need to count the actual ways we can basically paint it so that none of the adjacent sides have the same color. Okay, so let's go through the first test case. Okay, now the first test case is where we have we have one row. Okay, and one row will basically have three column. Okay, now let's say the rule is, so here we don't have any vertical, like we don't have any other rows, so we will not consider any vertical rules, but horizontal rule is that cell 1 should not be equals to cell 2, right? Now similarly goes for cell 2, so cell 2 should not be equals to cell 3. Okay, so that's it here. Now we basically need to find out how many valid ways we basically how many valid ways can one row be painted. Okay, so this is one row. Okay, now what we'll do, we have three colors, right? We have three colors, which is R, Y and G, right? Now let's say, so there are two ways this can be painted if you see here properly. So one is where we have, let's say, A, B, A. So one is where two colors will be same and one will be different. Now if you see, there are three columns, so we cannot put all three same, right? Because if you see, that will break our rule that adjacent sides have same color. Okay, so it should not have same color, so all three cannot be same. Now if you see, two colors can be same. Why am I saying that? Because on the sides we can keep two same colors. So if you see, A and A are same and B is different. Now here if you see, we are not breaking any rule because none of the adjacent sides are having the same color. Okay, so in this format, let's say how many we can keep. Can we keep red, green, red? Yes. Can we keep red, blue, red? Yes. Can we keep, similarly, go for green, 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 green. So in between we can keep red and blue. Okay, now similarly goes for blue as well. So blue, blue, and then blue, blue again, and then one is green and one is red. Okay, now if you see, none of the adjacent colors are same. Okay, now for this format where ABA is the, basically in the ABA format we will have 6 options, right? 6 options. Now if you see, now we can also keep in other format, which is basically A, B, C. So if you see, in this case also none of the adjacent colors are the same, and we can keep the colors in this way as well, because none of the adjacent colors are same and all are different basically. Okay, so in this case, if where all 3 colors are different, we can keep, let's say, a red, green, blue. Now again, what we can do, red, blue, green. Then again, what we can do, now it started with red, so maybe we can go with green, 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 maybe red, then blue, then blue, then red. Now red is done, green is done, now we can do blue. So blue, blue, then what we can do, red, green, green, red. Okay, so if you see now, here also we have 6 options. Okay, so this count is also 6. Now what is the total value? So if you see here, 6 plus 6. Now how is this first 6? So ABA format, basically ABA format is 6, and ABC format is also 6. So what will be the total value? Total value will be 12, which is expected here. Okay, now same way, so basically same way we'll be doing the other solutions as well. So if you see here, like from now on, like in this case, basically we tracked the colors, but we found out that there are 2 formats. One where we can keep all the unique colors, basically in this case ABC, and one where we can keep at least 2 common colors. Because like if we go below two common, which is like 3 common, so 3 common cannot be possible, because that will break our rule of having no adjacent colors. Okay, so now we need to basically find out how many rows belong to each type. So we have 2 types here, ABA and ABC. We basically need to find out that how many rows we can keep. So okay, so let's say one is same. So this is same type, this is different type. Okay, now in the same type, if you see, we have 6. In the different type we have 6. Okay, so now in vertical case, now vertical rules also matter. Okay, so in vertical rule, where like a cell cannot have same as the cell directly above it. Okay, so instead of tracking colors, we ask like, if row 1 was type S or type D. Okay, so if the above row was type S or type D, then how many type S or type D rows can be placed below it? Okay, so now what we can do, let's assume that row 1, so row 1 equals to, we have red, green, red. Okay, now we need to build row 2. Now this row is type S. Why? Because if you see, it is in ABA format, where the colors on the left and the right side are same. Okay, so now we need to build row 2. Okay, so in row 2, if you see, we need to find out how many type S we can build. Okay, so the rules are simple here. Now if you see, let's say the it is it will be in the format of A B A. Okay, so if this is the rule, then if you see, according to the R1, here will be the rule A, which is basically red. So A cannot be equals to red in row 2, okay, and B cannot be equals to green in row 2, okay, and the last one, A cannot be equals to yellow, which is basically the horizontal rule, okay. Now why I'm saying this? So basically we need to try all the valid options, okay. So type S, from type S to type S there will be three, okay, three rules, okay. Now if you see, now we need to basically try to build from row 2, basically from row 1, how many row 2 options we have if we try differently, okay. Now in this case the rules will be, so A cannot be equals to red, okay, B cannot be equals to green, okay, and the last one, which is A, so this is different, so in this case it will be A, B and then C, okay. So just a second, yeah. So this one, which is C cannot be equals to red, okay. So basically all A, B, C are different here, okay. So there will be two combinations here, okay. There will be two valid combinations for this case, okay. Two valid combinations, okay. Now let's say in the basically, like, if you come to the conclusion here, so same, where like, so this is previous row 1, okay, and this is, okay, this is type D. So if you see, so for type S, and this will be the new type S, this is basically the for the new row. So here there will be three options, and for type D there will be two options. Similarly for type D there will be two options, and there will be two options if we go type D to type D, and type S to type D there will be two options, type S to type S there will be three options, okay, from row 1 to the next row, okay. Now in this case basically every row depends on the row above it, okay. So we only have to track two numbers, how many ways it ends if it is type S, how many ways it ends in type D, okay, that's all. So if you see, now let's consider like the same type which is basically ABA. So same type equals to number of ways it is ending with type S, which is basically A, B, A, okay. Now another way is type D. So we basically need to find out the number of ways it is ending with type D, which is basically A, B, C, okay. Now let's say what will be the, so there will be a formula if you see here, okay. So there will be formula, what will be that from formula? Now we basically need to find out for the next row. So let's say if we say this new next row, then for next row we need to check the previous row, which is basically, so same, right? So if we say same into 3, which is basically we got here, so same into 3 plus different into 2, this will be the same for the new row, okay. Now if you say then another new difference which is going to be, the difference means ABC. If you see, so it will be same into 2 plus difference into 2. Okay, so this will be the formula now. So if we consider this example here, okay, this first example where same equals to 6 and different equals to 6, then in that case it will be 6 into 3 plus 6 into 2, which is 30, and then this is for new row, okay, where like we have two rows, okay. So in that case same will be 6 and different will be 6, okay, and then which will be 6 into 3 plus 6 into 2, and then again 6 into 2 plus 6 into 2, which will be overall 54, okay. So in this solution, let's say here if you see the solution, what we are doing here, so we have the mod value as given in the problem statement, because the value is increasing exponentially. That's why we are using mod every time we are calculating the new same or new difference, even at the time of the returning, because it expects in the integer format and it goes beyond long, okay, beyond the capacity of long. That is why every time we are doing modulo, okay. So if you see, for first we starting with same, which is 6. So for one row it will be 6, and for another row it will be 6, okay. I mean, if it is one row, then it will be 6 for both, okay, for AB pattern as well, for ABC pattern as well, okay. So this is basically the same pattern, the different pattern, okay. Now if you see, when we are calculating the new same, it means what we are doing, we are using the same formula. So same into 3 plus different into 2. This is the main formula which we are using to calculate, and then we are basically using the modulo. We are doing the modulo so that it goes back to the small size instead of going to the exponential size, okay. So every time we're reducing using modulo, and at the end what you are doing, we're updating the same and the different value every time, okay. So once it is updated, once the whole loop is done, we are returning the value, okay. So we are basically summing the same plus different and then doing modulo and returning it, okay. So let's see, let's try to run this solution, see how it works. Yeah, so both the solution, I mean both the test cases are accepted. Now we will try to submit it. Yeah, it's submitted. Okay, so let's go through the time complexity and space complexity. So what we are doing here, we are using a modulo, we are using another variable, and then another variable different, and then inside the for loop we are using two more variables, and then we are assigning back to the same variable, okay. So I think the space complexity will be constant because it is 1 plus 1 plus 1. I think it is 4, 3 plus 2 is 5. So 5 is a constant value. So space complexity will be constant. And then if you go to the time complexity, so the time complexity, we are starting from 2 and we are going till n. So it can run the loop n times if you don't consider the 2. So overall, if we go to the final time complexity of this program, it will be somewhere around big of n, okay. So the time complexity is big of n and the space complexity is a big of 1, okay. So I think in this problem, this is hard because of the intuition how we are going to think, not because how we are going to solve it. And even if you see the acceptance criteria, I mean the acceptance rate, it is 71.18%. So I think it is not that difficult. Yeah. Okay. So thanks for watching this video. Please let me know in the comment section if there is anything I can improve. And yeah, thank you, bye bye. Please do like the video and subscribe the channel. Thank you.